Hi guys, hope all of us are doing fine. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In our previous discussion, we had looked at a number of concepts which are going to be giving us results of various limits for different types of equations. And in this particular case, we have decided that there are some of the cases whereby we are going to see that the conventional methods which you have been using for evaluating limits such as substitution, and we can give this list of methods for factoring, and another method which we had listed for a conjugate among others are going to be giving us specific results. And we said that in case we come across this specific form of results which we are going to come across, which are going to appear in this specific form of infinity over infinity among others, we're going to see that these are going to be having a specific, of course, a reference which is going to be given in terms of determinate forms of results. And in this case, we're going to see that these specific methods are not going to be proving helpful in trying to determine, of course, limits of these specific functions in case they come up with these particular results. Now, we said that Lehobito came up with a specific rule which is going to be assisting us try to evaluate limits of such a kind of equations. And of course, this is going to be given in terms of what we refer to as the Lehobito's rule. Now, from our previous discussion, I've basically done a specific video on the concept of Lehobito's rule, but we can give it in summary form in a form of this specific function, whereby we're going to have a function of x and g given in this specific case. Now, as the limit of the value of x tends to c, we're going to see that we can give this specific limit in terms of the limit of the first derivative with respect to x over the limit of the first derivative with respect to x of this second, of course, polynomial. So this is going to be, of course, two polynomials over f and g given as such. So as the limit of x as x tends to c for this specific function is going to be given as the respective derivatives of this specific number. So in a sense, we can be able to find limits of various range of expressions, especially which are going to be of indeterminate form, using the Lehobito's rule, which I've given at the bottom part of my right side of the board. So in this particular case, we're going to try and solve this particular equation which I've given on the board using the Lehobito's rule. But we're going to contrast it with one of the methods which we have been using, of course, in our previous discussion in trying to find limits. So if we perform a substitution in this specific case, we're going to have the limit of as x tends to infinity of this specific function given in terms of x. And this is going to be particularly, so we are going to have this one given in terms of infinity raised to power 2 and 2 raised to infinity. And this is going to be giving us an indeterminate result, which we foresaid, which is going to be in indeterminate form given as such. And of course, we're going to see that if we use the Lehobito's rule, we're going to find a specific result, which of course is going to be handy for us. And I'm going to use this specific procedure at the lower section of the board and try to see what are some of the results which we're going to obtain. So we're going to take this specific, of course, a function in terms of as x tends to infinity over x, the square of x over 2x. And we're going to perform the first derivative of this specific function. So as the limit of this specific function as x tends to infinity, we're going to have the derivative of this numerator given in terms of 2x all over the derivative of the numerator. So the derivative of the numerator is going to be given in terms of 2 raised to power x, the natural logarithm of 2. And we're going to perform a rearrangement for this specific equation and have it given in terms of 2 natural logarithm of 2 of the limit as x tends to infinity of this specific function of x all over 2x given as such. So in this case, we are going to perform, if we try to do a substitution at this specific level, we are going to end up with these specific results. And therefore, we're going to do a subsequent, of course, differentiation in order for us to find, see what results we're going to obtain. And this is going to be in form of the natural logarithm of 2, the limit of this particular function as x tends to infinity is going to be giving us 1 all over 2x natural logarithm of 2. So we're going to perform a subsequent rearrangement of this specific equation and come up with 2 all over the natural logarithm of 2 and the square of that. So this is going to be a specific section of this specific equation which we are going to take this specific side. I hope that we have understood, we understand that one from the laws of this specific integration, and therefore we are going to have this one over. So the integration of this specific section of logarithms, I assume we understand it from that specific point. So we're going to have this one as a coefficient being taken as 1 over natural logarithm of 2, and that is going to, of course, have an implication that we're going to have a square of this specific section given as such, and therefore this is going to be remaining with the limit as x tends to infinity of this specific function of 1 over 2x given as such. So if we